take out a highlighter. When your numerator and denominator of a fraction are both polynomials, we have a rational expression. Polynomials, if you remember from grade 9, are any things with variables, powers, adding and subtracting. You just can't have square roots of x. You can't have exponents that are fractions. You can't have exponents that are x's. But even if you had just, wow, a big yellow blob, that is not. But if you had 3 over x squared plus 1, this would be considered a rational expression because 3 technically is a polynomial that just doesn't have any variables. But the ones that we're going to deal with usually have x's in the top and the bottom. We don't deal with a lot of these ones where you have 2 variables. We tend to mainly deal with just ones that have x's. And since in grade 11 we've studied up to quadratic equations with x squared, usually you'll see ones with x squareds somewhere in the fraction. A very important thing in rational expressions is talking about non-permissible values. You are not allowed to divide by 0. All right, here's some examples where square roots and x's and exponents. So if you had this expression, 3 would be bad. 3 would cause you to divide by 0, so we call that our non-permissible value for our equation. So let's look at example 1. It just says determine the non-permissible value. The easiest way, and the thing you're going to find we do a lot in this unit, is we always factor things first to see what we have. In part A, I can factor the bottom as a difference of squares to be x plus 3 and x minus 3. And once it's factored, it becomes easy to see what your non-permissible value are. Can you see that x can't equal minus 3, because that would make this first one 0. And x can't equal 3. Same thing in part B. Notice it's okay for x to be 0. The top can be 0 of a fraction. Your numerator can be 0. It's just a problem when you divide by 0. So on the second one, I go to factor again. Obviously, x and x makes x squared. It's 2 numbers that multiply to 16. 4 and 4, that'll make 8 if they're negative 8, if they're both negative. Excellent. So non-permissible value here. Well, normally there would be 2 when you have 2 factors, but do you see that they're the same? If x is 4, it would cause you to divide by 0. So those are our non-permissible values. Questions for practice on this one? 4, 5, and 8. And I'll give you 5 minutes to try those.